Example 3. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. There are 2 table sizes available. Small tables seat 6 people, and large tables seat 10 people. The equation 6x plus 10y equals 180 models this situation, where x is the number of small tables and y is the number of large tables. Letter A, graph the equation, interpret the intercepts. So because they specifically told us we need to interpret the intercepts, I'm probably going to graph this equation by finding the intercepts. So once again, I'm going to kind of break this. I'm going to find my x-intercept over here. I'm going to find my y-intercept over here. If I'm finding my x-intercept, I'm going to substitute a 0 in for y. So 6x plus 10 times 0 equals 180. 10 times 0 is simply 0, so I'm going to be left with 6x equals 180. And then I'm going to divide both sides by 6. The 6's will cancel. X equals 30. So I know my x-intercept is going to be 30, comma 0. So over here, I'm going to put an x-intercept on 30. Then I'm going to do my y-intercept, which means I'm going to substitute a 0 in for x. So 6 times 0 plus 10y equals 180. 6 times 0 is 0, so that leaves me with 10y equals 180. And then I'm going to divide both sides by 10. So y equals 18. And then the actual point, 0, comma 18. Now, if we wanted to graph that, I'm going to graph that. And so far, when we've been graphing our linear equations, we've extended them forever in both directions, and we've had arrows on both sides. Should I do that in this situation? And the answer is no, because we're talking about tables and we're talking about people, okay? X represents the number of small tables and Y is the number of large tables. If my X goes down here below 0, or I'm sorry, my Y, that's a negative number. That would mean I have a negative number of tables. That's not going to happen. I'm going to get to 0 and that's going to be it. So when you graph this line, you're going to connect both of your intercepts, which is your line, but don't extend and don't put arrows. This line stops in the first quadrant because we're stopping at 0 and we're stopping at 0. We can't have a negative number of tables. Now, the last part is it said that we have to interpret the x and y intercepts. So I'm going to look right here at my y-intercept. Then I'm going to go back and I'm going to say, okay, well, y is the number of large tables. Well, if y is 18, what is actually happening there? Okay, so what's happening is if y is 18, that means x is 0. So the interpretation in my mind would be we need 18 large tables, and I'm running out of room, to seat everyone if we don't use any small tables. So if we decide, you know what, I'm not using any small tables, I'm just going to use the large tables, we're going to need 18 of them in order to seat everybody in that room, because remember we have 180 people. So why wouldn't we just use large tables? Well, maybe we don't like 10 people at a table, or maybe 10 large tables won't fit in the room. Maybe they're just too big, so we have to kind of break it up with some small tables. I don't know. Interpretation over here, 30. Okay, 30 tables is a lot of tables, right? Maybe all small ones aren't going to fit in the room, but we need 30 small tables to seat everyone if we don't use any large tables? Letter B, find 4 possible solutions in the context of the problem. So, in the context of the problem is we're trying to figure out how many large tables and how many small tables we actually need in order to make this work. We have to seat 180 people. So, 4 possible solutions, we already know 2 of them. We found them. One solution we found was 0, 18, which means 0 small and 18 large. That will seat everybody. Or we also found 30, 0, which means 30 small and 0 large. That will seat everybody. But what if, 30 small tables aren't going to fit in this room? Or what if we really don't want 10 people at a table and we'd rather put them in smaller groups? What kind of other combinations could we come up with? Well, there's a guess and check method. We could just substitute values into the equation, or we could use our line. So I'm going to go look at my line, and I'm going to say, okay, well, if I'm looking at my line, this is not quite, I'm looking for like where it hits like an actual like box. And right here to me looks like it hits an actual box. I could maybe find another, the other one I'm looking at is maybe like right here. And I'm going to check that just to make sure. But if I find this dot, I'm going to go over to 10 and up to 12. Okay, so I'm really hoping that 10, 12 would be a solution, but I'm just going to check it to make sure that my graph is actually what I want it to be. So 10, 12, if I go back and look at my equation, I'm going to substitute 10 in for my x and 12 in for my y, and that better get me 180. So 6 times 10 plus 10 times 12. Okay, so let me grab my calculator. 6 times 10 is 60, plus 120 is 180, which is perfect, which means we need 10 small and we need 12 large. And then we have to do that one more time. So I kind of found one right here. That looks like to me it's at 20, 6. We're going to try 20, 6. So 6 times 20 plus 10 times 6. It's kind of like the reverse order here. So 6 times 20 is 120, plus 10 times 6 is 60, which is 180. So we could also work with 20 small and 6 large. There are some other solutions in there if you found them. Just make sure you're checking whatever you're working with, and also keep in mind you can't use a decimal of a table. Okay, so if I come here and I'm at like 6 and I'm going up, maybe 6, 14 would work. But if I tried 5, I don't think 5 would give us a whole number answer for a table. So just be careful with your answer and make sure you check it.